Okay, so welcome back, Level 1 NCEA physicists and earth-based scientists. Continuing on with the heat external, and today looking at the idea around heat transfer through conduction. Okay, so we looked at heat energy, and heat energy, also known as thermal energy, is the energy that flows from a region of an object which is hot to a region of an object which is cold. And there's three ways that this can occur, through conduction, convection, and radiation. And today we're going to focus on conduction. So conduction is how the heat energy flows through an object without the object itself moving. So solids, in particular metals, which we'll look at that later, are the best conductors and gases are the worst. The reason why is that in solids the particles are close together, whereas in gases they're wide apart. Okay, and if there's no molecules or particles at all, like in a vacuum, there is no conduction occurring like in outer space. Okay, so a poor conductor is known as an insulator. Okay, so in terms of thermal conduction in molecules, basically the molecules or particles vibrate more when they're heated because they have more kinetic energy, and the forces between the molecules or particles therefore pass that energy or that movement of energy onto the next one. Okay, and the stronger the forces, the faster the vibrations, so the faster the heat transfer happens by conduction. So metals are a case in point, very good conductors because they have electrons. And those electrons can actually move from one atom to the next metal atom. And it means that conduction occurs very quickly because it's very easy for the heat energy to pass to the adjacent atom. However, other objects like diamond are also very good conductors because they have very strong bonds between the particles. So one of the reasons, being winter, that we wear jumpers like this is because air is a very good insulator. It doesn't conduct very well. Okay, so what clothes do is they trap pockets of air around our bodies, and the more layers of this air that are trapped around, the greater the insulating effect is, the harder it is for the heat in our bodies to conduct out into the surroundings. Okay, animals do the same thing with fur and feathers. What they do is, for example, in a dog, the fur traps the air within the fur and traps the air around their body, so less heat energy is lost to the surroundings. So the way you can increase the amount of conduction or thermal transfer is in four ways. Okay, you can use a better conducting substance. So in our example here, glass is a poor conductor. It's more of an insulator due to its chemical makeup. If you replace that with copper, then the rate of conduction will increase for the reasons outlined for metals earlier. If you decrease the thickness of the substance, it also increases the rate of conduction because there's less particles for the energy to pass through. Increasing the area also increases the rate of thermal transfer, rate of conduction, because there's more particles for the energy to pass through. And finally, if you increase the temperature difference to the different parts of that particular object, for example here the copper, then you're going to increase the rate of conduction as well. So if you increase it, for example, to 100 degrees instead of 60, then you're going to get an increased rate of conduction. So in terms of finding the best conductor, an example would be you have 4 different rods of different metals. You basically stick a matchstick with a bit of wax onto the end of each of these rods, and you heat one end of the metal rod, and the matchstick, in which the wax melts first, is going to be the best conductor. Okay, so we'll do this experiment in class actually, and we'll actually observe which metals conduct the best, because the faster the conduction occurs, the faster the wax melts, and the faster the matchstick falls. I can also compare 2 different objects in terms of better conduction. So you basically have some gummed paper which burns first on the wooden side of the rod. This is because the brass actually removes the heat away from the paper and actually protects it from being burnt. Therefore, brass would be the better conductor in this example. Water, however, is not a very good conductor compared to metals. And the way you see this is by heating a boiling tube of water near the top of the water. So the water is going to boil and vaporize at the top, but you can still actually touch the bottom of the boiling tube because it's still cool, because the heat is not being transferred very effectively by the water. Okay, it's a poor conductor. And finally, as I've already mentioned, air, very good insulator. So we've already mentioned that air can be trapped by feathers or fur. It can also be trapped in cavities in your home. That's why how insulation works when you put in, say, pink bats into the roof. And also, when you go to sleep at night, those blankets and duvets do the same thing. They keep you warm by trapping the air, which insulates you and keeps the heat in you and not being sent out and conducted into the surroundings with heat loss.